So in the last lecture, we ended up with the topic that is dehydrohalogenations of haloalkanes. And we saw that the structure which has more alkyl group around the CC bond and the C double bond C, that will be the major product. Okay, we did a few questions also, and let us try a few more, and then we will write a rule. Please write with me. Write the major products. For following. Okay, what was the question that I gave you last time? This is CS3, this CS3, this CS3 here. So first of all, you will identify the carbon atom which is having halogen. I hope that is very easy for all of you. So we will identify the carbon atom that is containing halogen, and then we will see what are the carbon atoms that are adjacent to this carbon atom. So this carbon atom is adjacent, and we have this green carbon atom which is adjacent. So you have to make sure which of the following. If I make a double bond with blue and red, then will that give me more substituted alkene, or will the bond be with blue and green, or blue and red? So one thing you have to choose. Similarly here also, what I can say, let me get this blue here. This is also blue. Okay. Now if I talk for the second structure, then I have the options of this carbon atom, and I have the option of, let us say, this carbon atom here. So these are the adjacent carbon atom where I can make a pi bond. If I look at this last structure here, then I can say that, see, this is the carbon atom, and it has this carbon, which is adjacent, and then it has this carbon, which is adjacent. Okay, and then it has which carbon? And it has this carbon, which is adjacent. Let me get it what color? Pink, maybe. Okay, so this is these are the 4 carbon atoms that are adjacent to this alpha carbon that is on that is having Br group. So the double bond will be with one of them, and you have to write the major product here. Okay, you have to write the major product here. Do one thing rather, write all the products, predict all the alkenes that can be formed. Let me write all the products here. That will give you a good practice, and then you can write which is the major one. Right. So I hope I can write the answers as of now, because I have shown what you have to do. You just have to remove the Br. You just have to remove the Br. In the first structure, it will be everything same. And there will be a double bond with this carbon, plus there can be a double bond with the carbon here. Second structure, we have, there can be a double bond with this carbon atom. I have to remove the iodine. Please remember that. Remove the halogen, write the structure as it is, and see where you can make the double bonds. Now, in this case, I can have a double bond. These two CH3 will be as it is. There will be one CH3 here and a double bond here. This can be one structure. Wait a second, is that right? No. This cannot be one structure. Why? See, you have to remember this red carbon here. It does not have hydrogen, no hydrogen. Right? This carbon, it does not have hydrogen. If it does not have hydrogen, then what is going to happen? There will be no abstraction of hydrogen from this side. And if the hydrogen is not getting abstracted from this side, then I have only 2 choices, that is the green carbon and the pink carbon. So I can make one like this. And the other I can make is CH2 like this. Okay. I hope now you can identify which is going to be the major. So please write in the chat whatever I have written here. All of these are A. A, and this is B. So for the first reaction, which will be major, A or B, please write in chat. Which one will be major, A or B? For the first one, please write in chat what will be major. Yes, Samira, correct. Salman, correct. Waiting for others. We did this in last class also. Saf, Nabil. Come on. What will be major for the first reaction? Correct, Khalid. What happened, Nabil Khan? What will be major? Nabil, are you there? Can't hear you. Yes, correct, Saf. Very good. Okay. Those who have answered, please write for the second one. What will be major? The second one, which structure will be major, A or B? Yes, Salman, correct. And Nabil, तो कुछ बोलिए ना, A or B, what will be major? You tell me what you're having struggling or something. Yes, Khalid, correct. हाँ Nabil, बताइए. Okay, for the first one or the second one? Your answer is for the first one or the second one, Nabil Khan? Yes, Samaira, correct. Correct, Nabil. Okay, fine. I hope you guys can answer now. In the first structure, we see that this is going to be major because it has more alkyl group attached on the double bond. Here, this is going to be major. And here, this one is going to be major. Okay. And why there is no bond between the red and the blue? Because this red one does not have any hydrogen. So the beta elimination from the hydrogen, beta elimination of hydrogen from the beta carbon cannot take place. And that is why here we will not get any double bond for the red and blue. Now you will write. Did we write ZZEF rule or ZZEF rule last time? I don't think so, no? Yeah, okay. Right, next. ZZEF's rule. Okay. It is written as ZAITSEVS, but it is pronounced as ZZEF's. Okay. Now, this rule is the same thing that we have written. Please write. During elimination reaction, hydrogen from that carbon is removed. Which bears lesser number of hydrogens and forms more substituted alkene. Okay. In short, you will just write in elimination more substituted alkene is preferred. So the alkene which is having more number of alkyl groups around the double bond. Right, next. So they can ask you a direct question. They can ask you a direct question. Reaction of haloalkane with aqueous KOH gives alcohol via substitution. but reaction with alcoholic KOH gives alkene via elimination. Explain. So let us write the answer first, then I will explain to you guys. Okay, so right. Since alcoholic KOH contains alkoxide ion, which is stronger base, due to larger size and high charge density. It can eliminate hydrogen from beta carbon. And forms what? And forms alkene. But if I look at aqueous KOH, there we have, but in aqueous KOH we'll write, but in aqueous KOH, hydroxyl ion, OH negative, ion is present. Which is a weaker base and good nucleophile due to smaller size. Hence, it cannot eliminate beta hydrogen. Hence, it cannot eliminate beta hydrogen and gives alcohol via substitution. Done, everyone? Yes or no? Please tell me.
1 minute, sir.
Okay.
Sir, can you show the questions? The question I have. Yeah, officer.
Okay. Now listen. Why is this happening here? Why is this happening? Please stop writing and listen now. If I have alcoholic KH, the ion that I will be getting is alkoxide ion. That means RO negative. RO negative is what it is. Mostly if we take alcohol, that is ethanol, so it will be what? C2H5, that means CH3, CH2, O negative. If I take aqueous KOH, please don't try, listen. Then we will have only one ion, one anion, that is OH negative. And let us suppose we have a simple haloalkane such as this carbon with hydrogens here, this carbon with one of the Br and the other two are hydrogen. Okay, now this carbon is going to get obviously a delta positive charge. It's going to get a delta positive charge, right? And it will be, if this carbon is delta positive, that means it will be more electronegative and it will be attracting electrons. Similarly, this carbon will get a slight delta positive charge, and this hydrogen is also going to be what? Delta positive, because it is attached to a carbon atom, which is further attached to carbon atom, which is further attached to bromine. So due to this bromine pulling electrons, this inductive effect will be set up in all of the atoms. Now this hydrogen is also delta positive. Now here this CH3CH2 O negative, it can either attack on this carbon atom, okay, or it can attack on this hydrogen atom, right? Or on this hydrogen atom. Same thing goes for OH negative also. OH negative can also attack on this carbon atom, and it can attack on one of the beta hydrogens. Okay, one of the beta hydrogens. Now, obviously, both of the things, please listen very carefully. Obviously, both alkoxide and OH negative, they want to attack on the carbon atom that is having a delta positive charge, because that delta positive will be very high. This positive charge on this carbon will be the highest because it is just attached with a halogen, which is more electronegative, right? This hydrogen will be having less positive charge than this carbon atom. But you have to remember that this CH3CH2O negative is what? It is very large. That is why this attack cannot take place. This attack cannot take place. And obviously, if OH negative has a choice, it is a small, it can attack this carbon atom also and hydrogen atom. So obviously, it is going to automatically go towards the carbon atom because it is having more positive charge, and OH is having negative charge. So positive and negative, they will attract each other. OH negative can automatically make a way through the through all these hydrogens and attack on the carbon atom. But that cannot be done by alkoxide ion due to its large size. Also, this alkoxide ion, it cannot wait to get into the way and go towards that carbon atom because it is having very high charge due to the electron releasing tendency of CH2, CH3 groups of the alkyl groups. Now, these CH3, CH2 group, they're pumping electrons on the oxygen atom. It is getting more and more negatively charged, and that is, it has to react fast. So it cannot wait to make a way towards the carbon atom. It will look at the hydrogen. Hydrogen is having slightly positive charge. It will dump all of its electron on this hydrogen, and this type of reaction is going to happen. This hydrogen will give the electrons here, and this Br will leave, and you see elimination reaction happening. But OH negative, it will not attack on the hydrogen atom because it is small. It can make a way, and it is not getting electrons from somewhere else also. There is no carbon or alkyl groups which are giving more and more electrons toward the OH negative. OH negative is on its own, and it will just attack on this carbon atom. So is this clear? Yes or no? Please tell me why alkoxide ion attacks on the beta hydrogen, but OH negative, which is also having a negative charge, it attacks on the carbon atom. And this is acting as a base because it is abstracting hydrogen. But this OH negative here, it is acting as a what? It is acting as a nucleophile, which makes a bond with carbon atom. Is that clear? Yes or no? Please tell me, all of you.
Yes, sir.
Yeah. Samaira, Nawal, Nabil, what about you guys? Clear sabko?
Yes, sir.
Yes, sir.
Okay. If you want to write this down fast. Can I move forward? Yes or no? Please tell me.
No, sir.
No. Okay. Okay. Meanwhile, while you guys are writing, can you attempt this question here? What happened? Chlorobenzene बनाना है? Chlorobenzene. Method of preparation of haloarenes. At least flip some pages. Let's flip some pages, look at the notes and answer it. Ideally, you should be revising this, all of these things. No one. That's on it. Okay, Khalil has answered. Khalil, आप फंस गए. What about others? Khalid, Salman, Samaira, Nabil. How many methods of preparation? Acha. Okay, Samaira. Okay, Nabil Khan. What about others? Saif, Minashi. Okay, Nawal. Okay. Okay, Nabil Khan. चलिए खुद बताइएगा आप लोग, है ना, in the next class whether you have given the right answer or wrong. Okay, Khalid, देख लीजिए एक बार स्क्रीनशॉट ले लीजिए. This was asked in this year's NEET जो परसों हुआ था शायद. Take a screenshot, take a screenshot. चलिए. Right, next, reactions with metal. Number 1, reaction with magnesium. For this you will write, when alkyl halides react with magnesium, in the presence of dry ether, they form a compound with formula RMgX. And this RMgX is called Grignard reagent. It is very important thing, Grignard reagent. So we have this, in this RMgX, we have R group, which is bonded with magnesium, further bonded with halogen atom. So this part, that is R, which is the organic part. This is the metallic part. And the compounds which have carbon and metal bond, these type of compounds are known as organometallic compounds. Organometallic compounds. So if you look at the general reaction of Rx, any haloalkane with magnesium in the presence of dry ether, it is going to give me RMgX. Now, the most interesting part of this reaction is when alkyl group is present and it is attached with halogen atom. Please stop writing and listen now carefully. Okay, please listen carefully. When the halogen atom is attached on alkyl group, this alkyl group and the carbon containing, they get a delta positive charge due to the electronegativity, higher electronegativity of halogen atom, and this gets delta negative. But as soon as we react with magnesium, now what is happening here? This magnesium is what it is? Metal, and metal has a tendency. The definition of metal is that it has the tendency to give electrons. It has the tendency to give electrons, and if it has the tendency to give electrons, then it will give the electrons like this, and this R will get a negative charge. R will get a negative charge. Now this opens up a lot of reaction that we can do now, because since this R is getting a delta negative charge, we can have some electrophile this electrophile will be attacked by this R group. Okay. Now, in this case, in all of the, wait a second. Most of the compounds that you see of organic chemistry, they are with carbon. Carbon can be attached with OH, carbon will be attached with nitrogen, carbon will be attached with halogen. These are the main things. Carbon, hydrogen, oxygen, nitrogen, and halogens. Only 5 classes. So you can either have organic compounds, 90% of them will have carbon, hydrogens, nitrogens, oxygen, or any of the halogens. Now this completes the 90% of organic chemistry. Now, if I have carbon bond with hydrogen, they have almost equal. They have almost equal electronegativity. That is why carbon does not get any kind of charge. But if it is attached with nitrogen or oxygen or halogen, then what is going to happen? It will always get a delta negative charge. Now that restricts a lot of reaction. And in order to get some different type of products, we react this with Grignard reagent and form RMGX, in which the R is having a delta negative charge, which can attack on some electrophilic site, electron poor sites. Okay, so that is why this Grignard reagent is very, very, very important. It is used in the next chapter, the next chapter, and the next chapter also. Okay, and it is in this chapter also. Now, this type of reaction in which what we are doing here, it is having a positive polarity, and here the R negative is having negative polarity. So this type of reaction are known as Umplong reaction. Umplong means reversing of polarity. This will not be asked, but Umplong reaction. Okay, आगे किसी को chemistry पढ़ना होगा, so you will be happy that you know what are Umplong reactions. But the reaction in which you change the polarity, you reverse the polarity of the reagent or the substrate here, they are known as Umplong reaction. Please write this down. We can write some more examples here. I'll be writing DE for dry ether. I mean, you can also have something like chlorine, doesn't have to be always bromine. This will be let me also write the name. So this will be ethyl magnesium bromide. The first structure here is ethyl magnesium bromide. This is phenyl magnesium bromide. Write the examples down. Let me know when you are done.
Chloride.
Sorry. Thank you.
Sir, in the benzene ring, is there any particular order in which we should represent the bonds?
No. तीन bond बनाइएगा पर लेकिन, okay, and also it should be alternate. I mean, you can draw this also, and you can draw this also. Both are fine. Or you can draw just a circle inside it. That is also fine.
Yes, sir.
Now, there is one more thing that you should be wondering. What is dry ether? How many of you think? Please raise your hand very fast. Is dry ether solid? Raise your hand if you think it is solid. Dry ether, raise your hand if you think it is solid. Okay, you can lower your hand. Okay, fine. Two of you guys think, okay. Okay, raise your hand if you have no idea what the phase of dry ether can be, liquid, solid, or gas. Raise your hand if you have no idea. The staff is not, okay, fine. But by looking at the name dry ether, what do you think it would be? Samaira? Okay, Nabil is saying that it is like gas dry ice. Actually, no. Ether is no. It is not going to be gas. It is going to be liquid. But why it is dry? How can a liquid be dry? Now, dry here means absence of water. What does this mean? It means absence of water. That means we are preparing this in anhydrous conditions, in the absence of water. So dry does not means it is not a liquid. Just means that we don't have any water content, not even moisture, not even 1 molecule or 2 molecules of water should be there. Now, why is that? So the CBSE will ask you a question. They will be go like Grignard reagent. Please write this with me. Grignard reagent is always prepared in anhydrous condition. In anhydrous condition, explain. So they have asked a lot of things here. They have asked, what is Grignard reagent? You should know what is Grignard reagent. They have asked, do you understand what does anhydrous means or not? And then you have to give the explanation why it is not prepared in the presence of water. That is the third thing that they are going to ask. So indirectly, they are asking three things, no? And directly one thing, right? Since Grignard reagent is very reactive in nature, now you will ask why it is reactive in nature. Let me explain that also. RMgx, magnesium is giving electron, magnesium is group 2 metal. I mean, I am writing just delta negative here, but this bond will be completely broken and this will have a negative charge, almost negative charge it will be having, a very high negative charge it will be having. Now imagine a carbon atom which is not even electronegative, so electronegative hota, then it would have the tendency to keep and hold up the electrons, but it is what it is, not an electronegative element, and it is getting a negative charge, so it will be highly unstable, and it wants to give up these electrons and dump these electrons to someone. So it's very reactive in nature, due to which, why it is reactive? Because negative charge is on the less electronegative atom carbon, due to which it's very reactive in nature, due to which it reacts even with moisture and gives alkane. So suppose you were trying to make Grignard reagent, so you'll be starting with, let us say, CH3Br or something, and then you will be treating this with magnesium. And what did you form? You form CH3 magnesium bromide, right? Methyl magnesium bromide. Now this is having delta negative charge, high delta negative charge, then followed by, and let us suppose you have some water content. So water content is what? H2OH with OH. Now this H will be having delta positive charge, right? And obviously very high delta positive charge because it is attached with oxygen atom, which is very highly electronegative. This CH3 negative will quickly attack here. This bond will break with CH3 and Mg, and you will be forming CH3H. What is CH3H? CH4. What is CH4? Methane. What is CH4? Methane. Plus here we have magnesium bromide and the hydroxide. Okay. Now we were trying to prepare Grignard reagent, but due to the presence of pani, what happened? Pani fir gaya. Due to the presence of pani, what happened? We got alkane. Write this down fast. Let me know when you're done. Did you guys understand why the Grignard reagent is always prepared in anhydrous condition? Yes or no? Please tell me. Nabil, Khalid, Khalil, Minashi,
Yes, sir.
Samaira, Salman.
Yes.
अब लग रहा होगा ऑर्गेनिक केमिस्ट्री आ रहा है, yes or no? 11th क्लास में तो सब ऐसे रहते हैं, ये क्या है भैया? I hope 12th standard is a bit better. You understand things, why it is happening, how it is happening. Yes or no? Please tell me. There are a lot of reasoning in organic chemistry that you are going to see in 11th and 12th standard. Done? Nabil is done.
1 minute, sir.
1 minute. Okay. Those who are done now, try this question. This was also asked in this year's NEET. The correct IUPAC name of the following compound. Now listen, I'm just helping you guys and how you have to attempt this. First thing is that you will see the functional group. If all the functional group are same, it is all. That means you don't have to look at the functional group now. Look at the parent. Look at the unsaturation also. It is all AN, 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 AN. That means you don't have any wrong or right answer on the basis of unsaturation also. Look at the parent. It is hexane, 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 hexane. Now look at the substituents: bromochloromethyl, bromomethyl chloro, bromomethyl chloro, bromochloromethyl. Now the only thing that they are playing with is the numbering, because everything else is same, right? So they are playing with the numbering. You identify the correct number and your question is done. So whenever you are giving competitive examinations, then you have to see two things. First thing is how they have, आपको ऐसे गिफ्ट में मिला है सवाल, and how they have packed the question. तो पैकिंग देखिए आप पहले. Look at how the question is packed. Then you will know exactly what you have to do and how to do it in less time. You don't start with the correct IUPAC nomenclature. You will go with the functional group unsaturation that will be taken down. You just see hexane, 4-ol, hexane, 3-ol, hexane, bromochloromethyl, bromomethyl chloro, bromomethyl chloro. Okay, only numbering I have to do. Try this one. Let us see how many of you are getting the correct one. I hope you guys remember the criteria for numbering. Functional group, it should get the lowest number. If not, then the double bond. If not, then the triple bond. If not, then the substituents. So यहाँ पे तो I hope you can see what is the functional group and नंबरिंग नहीं हुआ अभी तक. जल्दी कीजिए नंबरिंग. Okay, Khalil, we will see. Khalil has given an answer. Waiting for others. Okay, Samaira. After numbering, you will boil it down to at least 2 options. Then you have to remember choice hota hai to you have to look at the alphabetical order, right? हाँ, मीनाक्षी ने वही गलती कर दी. Minashi did not see the alphabetical order. See, 2 can never be correct. Why? Because after bromo we are getting methyl. नहीं भाई, B के बाद C आना चाहिए. Chloro should come before methyl, right? So this option is obviously not correct. This option is not going to be correct. Now Minashi is correct. Correct, Nabil. Very good, guys. Correct, Khalid. Okay. So those who are wondering what is the answer? Yes, Nabil Ahmed, very good. Now we have this OH here. So we can start from 1, 2, 3, 4, or we can go 1, 2, 3. So I will be going 1, 2, 3. So this will be 1, 2, 3, 4, 5, and 6. So obviously the second option is not correct. And 6 bromine will not be correct. 6 bromine will not be correct. The only option that I have is 1 bromo. That is fourth option that will be correct, right? Because bromine is in the first position here. Okay. Chaliye. All right, next. So fourth option सही है. Most of you have given the right answer. I mean जितनों ने भी दिया सही ही दिया है. बाकी थे जिन्होंने नहीं दिया है. Okay, right, next. Reaction with sodium. Now, in reaction with sodium, we'll be looking at 3 reactions, and these 3 reactions are generally, these are very similar reaction. Wood's reaction, Fittig reaction, and Wood's Fittig reaction. Okay, so write the number 1, Wood's reaction. Okay, the Wood's reaction. In Wood's reaction, you'll write when two same haloalkane reacts with sodium in the presence of dry ether, यहाँ पे कोई नहीं पूछेगा आपसे why we are using dry ether. You know why? Because you must have learned this in 9th standard or 11th, 10th standard also, that sodium, if you add sodium into water, it will be explosive, right? That is why we use dry ether without any presence of water. Dry ether, they form alkanes. Containing double the number of carbon atoms and the reaction is called Wood's reaction. The reaction is called Wood's reaction. So what happened here? We have 2 haloalkanes, RX, and we will be having 2 sodium atoms also. Okay, so they make a bond like this, and these two are our group. They make a bond like this. Okay, so like 2 RX plus 2 sodium in the presence of dry ether is going to give me R bonded with R. First of all, learn how to make the product. See, If you have CH3X, देखिए यहाँ पे 2 लिखने का मतलब it is not that we are taking 2 molecules. We are saying that for this reaction the stoichiometry is 2. That means for each product that is formed we need 2 reactant. For each product formed we need 2 reactant. That is just the meaning. If even if I write CH3X and I react this with 2Na, I react this with Na only, then also it is going to give me what? CH3. Plus here you can write NaX. In this case, okay, let me take Br here, and it will be NaBr. Okay, this reaction is completely correct, but it is not stoichiometrically correct. Reactant wise, product wise, it is correct, but stoichiometrically it is not correct. Okay, so please remember, we will be getting product that is going to be having double the number of carbon atoms in Wood's reaction with sodium and dry ether. Okay, so this will be 2CH3. So if they ask you what will be the product if you react methyl bromide with sodium and dry ether, then you will write it will be ethane. It will be what? It will be ethane. Now, if I have a reactant such as this, here the bromine atom is on second carbon. It is on second carbon. Okay. Now what you will do? You will orient again. Same Na is there. The presence of dry ether. Now please listen very carefully. Please listen very carefully. Don't write now. What you are going to do? You are going to orient this molecule in such a way that bromine atoms are facing each other. You'll make 2 molecules. You'll make like this. Br and Br like this. Can all of you make this? Yes or no? Please tell me. सबको दिख रहा है? Yes or no? अरे हाँ ना जल्दी बोलिए. Can all of you orient this? These are same molecules, right? Yes or no? Samaira, Nawal, Nabil, Minashi, tell me. I just need a confirmation. ये अगर हो गया आपसे, then you can form the product very easily. Then what you are going to do? You are going to remove the bromine atoms and then just stick them together. Okay, that means the carbon atom which is having halogen, it is going to be attached with the carbon atom of another molecule which is having bromine. So this is the answer that you are going to get, plus NaBr. Now obviously it is not balanced, but I'm still telling you, you will be getting reactions like this, questions like this, and you have to make this product. Stoichiometry को दिल पे नहीं लीजिए. Questioner के पास liberty होती है, वो आपको stoichiometry नहीं दे सही से. Okay, but you have to make this product. If the question is writing only one molecule, it does not mean there is only one molecule. It means there will be plenty of molecules present, right? It is just showing what is the reaction is happening, what are the reactants and products. Now, let us do another one. Try for this one. Now everyone will know what is the product of Wood's reaction. That double the number of carbon atoms is there, but how to orient them, that is the main thing here. That is the main thing here. Okay, चलिए जल्दी कीजिए इसको. Then let me see what answer you are getting. Now, if you don't want to make the bromine, then what you can do, you can just face the carbon atoms having bromine. So we'll mark it as blue like this or some circle. Make one molecule without the bromine, and this is the blue one. Or you have marked it with some darker circle, you have highlighted it, and then just make another molecule in which both of these carbon atoms are facing each other. Right? Both of these carbon atoms are facing each other, and just make a bond like this. This is your structure. I hope this is getting clear. Yes or no? Please tell me.
Yes, sir.
Yes. क्वेश्चन में क्या करेगा पता है? इसका नाम दे देगा. They will give you name of this and they will ask you the name of this product. So IUPAC भी हो गया, Wood's reaction भी हो गया. If you have some cyclic structures,
Sir, can we do it like this, sir?
Like
I
this.
sent you
Like
picture in WhatsApp.
okay. हाँ, same है ना, देखिए. Everything is same, yes or no? Try to name it and name this one. Or I mean, it is just the orientation that is different. ठीक है, एकदम सही किया आपने.
Okay,
No
sir.
problem in that. Okay. Similarly, if you have something like this, just say Cl here plus sodium, presence of dry ether. Try the product. Try the product, all of you. Done, everyone? Yes or no? Please tell me.
Done, sir.
Yes, sir.
I hope you have made a product. Like this. If you have doubt with your product, send me. Okay, Nabil has sent. हाँ सही है नबील आपका. डाउनलोड भी नहीं करना पड़ा, थंबनेल से ही पता चल गया सही है आपका. वेरी गुड. You can also have benzene ring with Br plus sodium. Br नहीं, any halogen can be here. And what you will be making? देखिए आप इसको ऐसे ही बना सकते हैं. There is no issue in that. बट थोड़ा एस्थेटिकली प्लीजिंग नहीं लगता है, और कोई बात नहीं है, आप ऐसे ही बना सकते हैं. For practice, make ugly looking structures rather than wrong structures, I would say. So if it is looking ugly, it is fine. Generally in the books, you will see that they have drawn it like this. Okay, so biphenyl or diphenyl. सैफुल्ला ने भी आंसर भेजा है. सही है सैफुल्ला, वो भी सही है. वियर्ड लुकिंग बट करेक्ट है ना. वियर्ड लुकिंग बट करेक्ट, राइट सैफ? यस और नो?
Yes, sir.
नो प्रॉब्लम इन दैट. चलिए. All of you try this one. Cyclohexane with a Br group here, with a CH3 here, plus sodium and dry ether. ठीक है, and send the answers. ठीक है, इसका आंसर दीजिए.
Sir.
Nabil, wait a second. Yeah, very good, correct. नहीं Samira, see, you make both of these two structures, and the carbon atoms containing Br, they should face each other. वो बनाइए आप एक बार Samira. Okay, we'll have two structures in which the carbon atom which is containing bromine, it should face each other. They should face each other. Try to make that. Yes, Saif, correct. You'll know what I'm talking about, Samira. Okay. Yes, Samira. Now you understand what I'm talking about. Minashi. Yes, very good, Minashi. Nahin. I will ask same thing to Khalid. Khalid, try to make two structures in which the carbon containing Br, they are facing each other. Carbon containing Br, carbon containing halogen atom facing each other. You will understand what I'm talking about. So I hope you can see how a little atom, how a little CH3 group is messing your heads up, right? Huh. Correct. Fine. Correct, Salman. Khalid, waiting for your correction. Khalil, what about you? आपने नहीं भेजा answer. Khalil, are you there?
Yes, sir. Sir,
Send it.
sir, can you give me your number once again?
Oh,
I don't have my phone.
so you don't have your phone. Okay, I will send. इंडिया आ गए हैं क्या आप?
Yes, sir.
हाँ, अच्छा. So हजारीबाग, right?
No, sir, Jharkhand.
हाँ, तो झारखंड में कहाँ?
Jharkhand में
हजारी
धनबाद.
धनबाद, नॉट हजारीबाग, धनबाद. हजारीबाग भी झारखंड में ही है, पता नहीं आपको?
Yeah,
धनबाद के बगल में ही हो. हाँ हाँ. तो धनबाद as in धनबाद or some nearby village or city?
A nearby village, nearby town actually.
Nearby town. Okay, what's the name?
Jamadol.
Jamadol.
Doba.
Sorry?
Ramzan.
Ramzanpur. Okay. How far is it from Dhanbad?
It takes about 30 minutes to get to
30
Dhanbad.
minutes, like 17, 18 kilometers. Okay. My grandfather was a graduate from ISM Dhanbad. He knew Dhanbad a lot, but okay. Khalid has sent me another answer. I have sent you the number by the way. Oh, okay. I think my mistake. I have to add +9 over 5309807. Nawal is not here. Nawal got disconnected. Okay. अब सही है आपका. Now it is correct. You got it, Khalid? What I'm talking about? Yes or no? Please tell me.
Yes, sir.
Okay. Now, once we have practiced how to make the product, let us see what is happening underneath. And mechanism we will write, okay? So the structure for this will be CS3 group here and CS3 group here, okay? Write the mechanism. So the actual mechanism that is of Wood's reaction, it is a bit complicated. It is single electron transfer mechanism, but we can understand it in a concise way also. In reaction, we have sodium atom. So first of all, sodium being a metal, it will dissociate into, I have two sodium atoms, it will dissociate into two Na positive and two electrons. Now, when I have Rx, here what is going to happen? The two electrons will come and they will see that this R is delta positive because it is attached with electronegative atom. This two negative, they will attack on this R group, okay? And as it is attacking on the R group, one of the bonds will break like this. The CX bond will break. Now you have to remember the CX bond contains one electron from carbon and one electron from halogen. But the halogen is taking both the electrons. Now carbon is one electron less, but it is getting two electrons. So overall, what will happen? This R will get a negative charge plus X will get a negative charge. I hope you understand why R is also getting negative charge and X is also getting negative charge, because X is taking one electron of carbon, but the carbon is getting two electrons. Also, if you look at the charges in the reactant, it is two negative charge, and in the product also two negative charge. So charge wise also it is balanced. Now what is going to happen? This R negative from here, it will react with the another Rx molecule, which is delta positive and delta negative. This R negative is going to attack on this carbon atom, and this is going to leave. So in a way, you can say that this R negative is acting as a nucleophile, since it is attacking on what? It is attacking on the carbon atom, and you are going to form RR. You're going to form RR. Okay. Plus you will get X negative from here. And if you write the overall reaction, then you will see that two Na positive and X negatives are there. So you are going to form the sodium salts of halogen, and RR will be formed. Okay, RR. यहीं से इंस्पिरेशन मिला था RRR के लिए. Okay, write this fast. Raise your hand now if you use Instagram. I have to ask something. Raise your hand if you use Instagram. नहीं, हम ऐसे किसी को कुछ डांटेंगे नहीं, हम नहीं कुछ बोलेंगे. Okay, only 2%. Okay, nobody else. Okay, then there is no use. Really? So Samaira, Nawal, Nabi, okay, all of these people, they don't use. Okay, since I hope you have written the reaction mechanism, now you'll write one thing. Write some remarks. First things first, this reaction is not applicable It is not applicable for two different haloalkanes. Why it is not? Because it gives mixture of alkane which is difficult to separate. So what is happening here? If I have, let us say, CH3 Br, and I react this with another molecule that I am taking of haloalkane is CH3 CH2 Br plus sodium in the presence of dry ether, then one product that you are expecting is that CH3 will get attached here. So it will attach on this CH2. So you will be getting CH3, CH2, CH3. But you should always remember that there will be millions of millions of molecules of CH3Br. So those two molecules can also get attached like this, CH3, CH3. So individual reaction can also happen, and this CH3, CH2 can go like CH3, CH2, CH2, and CH3. Okay. Since you are getting mixture of products here, that is, and all of them are having, one is having 2 carbons, 3 carbons, and 4 carbons. So their physical properties will be very similar. That is why it is very difficult to separate them. That is why it is very difficult to separate them. Okay, so it is not applicable for two different haloalkanes. Wood's reaction is when two same haloalkanes are treated with sodium, they will form alkenes with double the number of carbon atoms. Write this down. Another point we will write. Wood's reaction is not shown by tertiary haloalkanes. As they undergo elimination and what do they do? And form alkene. Okay, as I said, it is kind of acting as a nucleophile, but if that nucleophile gets bigger, if it gets bigger, tertiary carbon mein kya hoga? It will get bigger. So see how the reaction is going to happen. Let us suppose we have CH3 attached with carbon, CH3, any halogen atom X, and then CH3. So in the first step, what is going to happen? If we have two sodium atoms, this 2 sodium atom will give 2 electrons. This 2 electron will go to this carbon atom, and this bond will break, and you will get CH3, CH3, CH3 negative. This is the R negative that we have, and then it will attack the same molecule. Let me show the hydrogens here like this. CH3, CH3 and X. Now this carbon, obviously it is having what? It is having some positive charge, delta positive charge, this carbon atom. But this big tertiary carbon ion, it will not be able to attack on the, it will not be able to attack on what? It will not be able to attack on the carbon atom that is bonded with hydrogen. So what it will do, and also you can see it is attached with electron releasing group. Electron releasing group, what they will do? They will make it more and more reactive. So it will attack on the hydrogen atom. Okay, it will attack on the hydrogen atom. This hydrogen atom will further cleave the bond, give its electron here, and what is going to happen? You are going to get an alkene like this. So this will become CH3, CH, CH3, CH3 plus This molecule here, it will become CH2. This hydrogen is being abstracted. CH2 double bond, carbon, CH3, CH3. Okay, so this is the alkene that we are getting. And what is happening? Rather than substitution, we are having elimination because of the big bulky carbon ion, which is acting as a base rather than nucleophile. Now the rest two reactions, we will not write much because they are completely same as Wood's reaction. Just the reagents, sorry, just the reactants are changing. So you will write Pvt reaction. And you have already seen Pvt reaction. Now, in place of haloalkanes, in place of haloalkanes, we will have haloarenes here. And if you have haloarenes, same haloarenes, okay. Similarly, if you have substituted haloarenes also, then also it is going to work. For example, let us say you have something like this. Okay, so see, very easy thing how to make is, you have you have bonded. So these are the carbon atoms, right? Just after you put CS3 here and here. I mean, you can also put it like this. Just one carbon after, okay? आपने अगर ऐसे भी लिखा है ना, तभी कोई दिक्कत नहीं है. If you have here CH3, then also it is not a problem, because you just have to make sure that the CH3 molecule, the CH3 group, it is attached adjacent to the carbon atom bearing halogen, है ना? So both of these are fine. And यहाँ पे तो rotation allowed भी होगा, है ना? Because it is single bond, so rotation will be allowed here. And at the end, they will be having this position only, because CH3 CH3 एक जगह रहेंगे, so it will be having some steric hydrogens. This is the Pvt reaction. If you have to write the statement will be same as haloalkanes for the Woods reaction, but you just replace haloalkanes with haloarenes. So right next, the Woods Pvt reaction, the third one. In Woods Pvt reaction, we have one haloalkane and the other is haloarene. We have it is going to get. So in place of Br, we are going to have R. So this is alkyl benzene. which is methyl benzene, aka toluene.